Okay, so I hope you guys can see my screen. Hey guys, welcome to today's session on statistics for machine learning, AI, and data science. So this is the day 3 of this series. In today's session, we're going to cover the measure of central tendency, in which mean, median, and mode lies, and then we have measure of dispersion or spread, where variance or and standard deviation are there, and then we will talk about skewness, and then we will see some pattern code related to this. Okay, let's get started. So what do you understand by measure of central tendency? Any guess? Okay, let me tell you. Measure of central tendency are basically statistical measures that gives us an understanding where the center of typical values of dataset lies. Mostly we get the summary or average representation of data by measure of central tendency. Okay, so by measure of central tendency, what do we get? We get the average or the summary of dataset, and what we can see, we can get the understanding where the center of our data lies. Alright, so in measure of central tendency, we have three kind of measure of central tendency: mean, median, and mode. Okay, let me cover one by one. So mean, you know what is mean? Mean is the sum of all values in a dataset, and mean is the sum of all values in a dataset, which is divided by the total number of values. Suppose this is your dataset. You have 1, 2, 3, 4, 4, 4, 5, 7, 10, and 5. Suppose this is your dataset. So to get the mean or the average of this dataset, what we have to do, we have to add all these values and then divide it by the total number of the values. Okay, so 1 plus 2 plus 3, 4, 4, 4 plus 5, 7, 10, and here we go 5. And the total number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. So the mean of this data set is 4.5. So by this value, you can understand the average value from this data set. But let's say we add a bigger number here. Let's say, 100. So 100 is quite a bigger number comparing to all these numbers here, right? So you know what is the 100 is called here? The 100 is outlier. Guys, do you know the term outlier? Okay, let me just quickly tell you what is outlier. Okay, outlier is a data point that significantly differs from other data point. It's like odd one out. So we need to deal with outliers in in datasets, and why we need to do it. Outlier can skew statistical measure, making them less representative. So to maintain the accuracy of data analysis, we really need to deal with the outliers. Suppose you have 6 friends, and most of the friends has are around 5 feet to 5.5 or 6, and you have another very tall friend whose height is 7 feet 2 inch. That's quite wild, no? So that friend can be considered here as outlier in this case. Sure. So let me just show you how can we get the mean in using Python. Suppose, okay, this is our data set, right? That we just have calculated. Acha. Okay, so to find the values in Python, to use mean, median, mode in Python, firstly you have to import the NumPy and Pandas library, and you can use any other libraries. There are also more libraries, scikit-learn, then you have SciPy. All sort of this library can help you find the central mean of central tendency, measure of central tendency. Okay, firstly you have to import it. Import NumPy. Here NumPy stands for numerical Python. We do all sort of calculation with matrix. Matrix calculation are done here. Very complex calculation in Pandas. We basically use Pandas to do data visualization or to do data analysis. Okay, I will shortly come in the Titanic dataset explaining you how things are here. Before that, let me just show you. So you can see in this dataset, they are the same values that we have just written, and then we are calculating the mean here. So to calculate mean, you just have to write NP, which stands for NumPy. You can see we have written import NumPy as NP. So this as word is used basically to give a short name for NumPy. Acha. So where we are, yeah. So you can see we just have to write np dot what you want to do. You want to find the mean of that data set. Then in bracket you have to write the data set name, which is ds. You are finding 4.5 here. Now let's add 100, which is the outlier, right? 100. And now you can see that how drastically the value has changed. That was 4.5, and after adding 100 in our data set, the value of mean is 13.18, which is uh, quite large compared to 4.5, right? So to fix this issue, or to get the middle number in any data set, we find problem uh, when we use mean. We usually face this problem that the central value is not we don't get the central value correctly. To fix this issue, we are going to introduce a new central measure of central tendency term, which is median. Okay. Okay, so you know what is median? We use median to solve the issue that we found in mode sorry min. And median works perfectly with outliers. So when we have a lot of outliers in our data, we are going to use median. Okay, to find the median of any value, you have to follow few steps. That is, firstly, you have to sort the data in ascending order. Sort the data set in. ascending order, and then if the total value, if the number of total value is odd, you will simply just find the middle, you will simply just pick the middle value and that will be your median. If the total number or the length of that array is odd, then this is how you should do it. And if the length of that array or the data set is even, you have to pick two numbers which are in the center, let's say n1 and n2, and you have to find the mean of these two numbers. So in this data set, our uh, our total number is 10, which is even. So we have to get the two middle number, which is this two, 4 plus 4. So we can see in this case, the median is 4 plus 4 by 2, which is equal to 4. Okay, I just told you that median solves the issue that mean couldn't, which is with the outliers. Now I'm going to show you. You see, uh, in this case, the mean was, when we added 100, the mean is 13.18, right? But the mean is 13.18, and if we find the median of this value, which is 4, which is really around the mean value that we were getting before adding 100. So we can still get the central value using median, even if there is outliers. This is the specialty of median. And similarly, to get median, you have to use np dot median, np dot what you want to do, you want to find the median, and then the data set in the bracket, and then you got the median of the value. Okay. So moving to the next part, which is mode. So what is a mode? Mode mainly means the most frequent data in your data set. Most frequent data in your data set. Okay. So mode works both with categorical and non-categorical data, but it works very well with categorical data. Um, let me show you how to find the mode. Okay, so in this distribution of data, you can see the number that has repeated that is repetitive here is 4, right? There are 4 over here. So in this, to find the mode in Python, you cannot, okay, I have written this code to show you that you cannot do this in the similar manner. You cannot do just np.mode in and ds, because in numpy they don't have this kind of attribute. So to find the mode, you have to write this in this format: np.argmax, then np.bin count, then the data set you're working with, and then it will give you the mode. Okay, you see the mode is 4 here. Okay, then I want you to build this intuition. Suppose there are similar number of the number of fours here is 3, right? Suppose this data set contains similar number of threes. There are 3 threes in this data set. Now, if you want to find the mode, you see it is 3, but the frequency of 3 is similar to frequency of 4, right? Both are here 3 times, but we are only getting 3. So this is one issue, that NumPy functions returns only a single mode and may not be suitable for datasets with multiple modes. So to find multiple modes, you can use this pandas code. So the dataset has to be converted into the series, and series are quite similar as arrays. Okay, so then you have to just type ds.mode. Let me do it for you. Okay, so you see there are two modes, 3 and 4. We got it using pandas. Okay. Um. So we often have a lot of mode, usually 2 or 3 in our dataset. So 2 and 3 modes are quite tolerable in our dataset, but more than that will defeat the purpose of finding mode. And okay. So by these techniques, we know the middle value or the central value of our data, which is the main idea of measure of central tendency. Okay, so we are done with this topic. Now I'm going to show you how you can do it, because see, this data set is very small, right? I've just put some random value over here, but how can you do it with an actual data set? So to find an actual data set, you have to bring the CSV file over here. Firstly, in this part, I have to use the Titanic dataset, where the passengers who survived and who did not survive, we got the data over here of them. Yeah. So to find it, you can read CSV file from, let's say, SQL, from your Excel sheet, from any URL link, or from your any file saved in your local storage, I mean your laptop or PC. So we got the URL over here, and then Titanic data equal to pd dot read csv. PD we're using PD as pandas, and then the read csv reads the file of the Titanic survivor rate dataset. Okay, anyways, Titanic Titanic data dot head gives us the some of the values of that data. There are hundreds of data. This data set is very, very, very long, but we're just getting the top values, you can say. Okay, so you can say we have passenger ID, people who survived, then the classes, the name, then the sex and age, the ticket, fare, cabin. We have a lot of data over here. Okay, so we are going to use data that is numerical to solve this type of calculation. So we chose age data. Age data, I mean the age of the people who were in the Titanic that day, sadly. Okay, anyway, so age data equal to Titanic data, and in the third bracket you have age, and this age, by writing this sort of code, you will get only the age data. You see? Okay, so similarly, to find the mean equal to np dot mean age data, the the column, the age column, and then you're getting the mean. So by this number, what we can understand, that um, that the central value of that data set, I mean the people who were in that Titanic ship, mostly their ages were surrounded by 29.69 or something, and the median, you see the median is none over here, but we were supposed to get actual numerical value, right? So why we didn't get it? Because in the Titanic data set there are a lot of missing values, and maybe not surely the central two values were none, or if it was a odd, if that data set was odd, length of that data set was odd, the odd value was none. So that's why we are getting a none. But when we solve problems, we usually clean our data, and then the missing values, we deal with the missing values, so we won't find this kind of problem. And then similarly, to find the mode, we will use mode equal to age data dot mode and 0, and then we get this. Okay, standard deviation and variance, we will cover it shortly. Okay, anyways. Okay, let me introduce to a new topic, which is distribution. I'm introducing distribution because next we are going to talk about skewness. So distribution. Suppose you have a histogram, and the histogram contains the ages of people in one classroom. So let's draw a histogram. Okay. Sorry for my bad drawing. Anyways, uh, all of these columns are called bins. Okay, each of these columns are called bins. So suppose now we are making the bins smaller and smaller. So in the next part, we are making the bins very smaller. This, and similarly in this side, very smaller. And then again, we're making it more smaller. And some point, that outline of histogram, I mean this part, is so thin that it feels like a smooth line. Suppose by thinning the bins, we again and again and again and again, we're getting something like that, because it's so smooth. It's just like a line now. So since this distribution, we were talking about heights, right? And since this distribution is about continuous number, and there is an infinite possibility of heights, we are getting this kind of thing. And this kind of things is called distribution. This type of graph. Okay. A distribution represents all possibilities of values for a set of data and how often those values occur. Suppose by looking at this distribution, uh, if the mean is, let's say, the mean is 100, we can tell that you know there are a lot of values which are also around 100. Suppose 80, around 70, and then we have 110 or 120. Suppose this is your distribution. Your distribution looks some sort of this, and the mean value is 100. Then this represents a very this represent that your most of the values are not concentrated with 100. This represents a very tight diagram. Okay, now I'm going to talk about skewness. Okay, guys, do you have any question? If you have any question, you can drop in the comment box. Okay, I think we can move forward. So skewness, What does skewness mean? Skewness is the measure of asymmetry of distribution. So skewness is the asymmetry of distribution. It indicates whether the data is concentrated in one site. I mean, it gives you an idea where the data is situated. So it gives you the idea whether the data is concentrated on one side, and it also gives you a sort of intuition where the data is situated. Okay, so we have few type of skewness. We have positive skew, also known as right skew. Then we have negative skew, and then we have zero skew, or you can say symmetrical distribution. Okay, suppose if your mean is greater than median, then it is a positive skew, and your distribution should look something like this. You know, your right tail will be stretched out. And what do I mean by tail? These parts are known as tail. And you know what does it mean? It means that most of your outlier lies in this part. It means most of your outliers lies in your this part. Okay, so the example we just used, the mean was greater than the median, right? When we yes, the mean was greater than median. The mean came something like 13.68, and the median was 4. So you can guess that the skew for this type of for that type of data set will be this distribution. You will find this type of distribution for this, where the right side is stretched out and the outlier lies here, because you remember we just added 100 lastly, right? So the 100 lies somewhere here. And then we have negative skew. In negative skew, the mean will be smaller than the median. So your distribution will look like, some sort of this. You know, your left side will be very stretched out. And by this thing, you will understand that most of your outliers are situated here. This is your negative skew. And what if your mean, median, and mode are equal? then that type of data sets are called zero skew or symmetrical distribution. Zero skew or symmetrical distribution. Okay. So in this case, your mean, median, and mode will be equal, and your distribution will look some sort of, okay, it doesn't look symmetrical. So this is your mean value, and your distribution should look like this. You know, you can see the two parts are quite identical. So this type of distribution are known as symmetrical distribution or zero skew. Okay, so we are done with skewness. Guys, do you have any question till far so far? Okay. Then we have our next topic, which is measure of dispersion or measure of spread. Mm, yes, measure of dispersion, also known as measure of spread. Okay. Okay, so by measure of dispersion or measure of spread, you will understand how well your data is spreaded with the mean. So what is the takeaway from measure of dispersion or spread? That is how well your data is spread with mean. Okay. Suppose you have sorry. Suppose you have uh, two data set. One is, and this is your data set one, and this is your data set two. Okay. Two, 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 two. And you want to find the mean of this data set. To find the mean of this data set, we're just simply going to add all this, right? And by adding all this, we have 1 plus 1, 2, 2, 4 by 1, 2, 3, 4, 5. The total number of in that data set is 5, and we will get 10 by 5, which is equal to 2. And for this data set, the mean is 2 plus 2 plus 2 plus 2 plus 2, and the total number in this data set is also 5. So we are getting same result, right? The same mean or error. So how do we say that these two distributions are different? These two distribution are not going to look like same, no? So to find that, we will use that how well the data is spread with the mean. So to find this, we will introduce you to variance, and then in variance you have two formulas. One is for population variance. Guys, you can unmute yourself and ask any question if you have. Okay. And the formula for this is sum from I equal to 1 to the total number of data in that data set, and then each data point minus the mean of that data set, and then the total number of values in that data set, and sample variance n minus 1, and each data point of the data set, the mean of that data set. This is the formula for variance. Okay, so suppose you have 6 dogs. Okay, suppose you have 6 dogs or cat, whatever your favorite animal is, and we have a data set which is the height of dogs. Suppose your data set is something like that, 150 centimeter, 150 centimeter, 165, then 166, 170, 150, 160, 3, 3. These are the 6 data points of your height of your dogs. Okay, so what does the variance actually tells us? The variance is the average of the squared differences from the mean, right? So to find the variance, we have to firstly calculate a mean of this data set. Okay. 150, 160, and divided by 6. Can anyone calculate it for me? Just give me a minute, I bring my calculator. Okay, so just add these values: 165, 166, 170, 150 plus 160, and divided by 6. We have the mean value of the height of the dogs are 160. Okay, I guess I've just taken a lot of bigger values. The dogs aren't that tall anyways. Maybe in another universe. Alright, so this is the mean. So since we have short time, I'm just telling you what the variance mean, and I think you can do the calculation by yourself. Okay, so we have to put the values of the values, and we have to get the difference between the data point here, like 150 minus 160.66. then we have to square it, and we will do it for the rest of the data in our data set, and we will get a value. Suppose we get variance as 100, and the unit will be centimeter square, okay, because the variance gives us the what it gives, the average of the squared difference from the mean. So the value will be in square. But to describe the spread more efficiently, we use standard deviation, which is basically the square root of variance. Okay, so the standard deviation is 10. Now let me tell you what does this standard deviation means. Suppose this is your distribution of the height of your dogs, and the mean that we found is 160.66, right? 160.66. By the standard deviation, we will understand that after 10 unit, okay, let me write it. 170, 180, 190, 150, 140, 130, 120, and this is our mean. Okay, let it be. Anyways, this means one standard deviation. This means two standard deviation from right, two standard deviation from left, and then this means three standard deviation. Suppose one of your dog's height is you see 170. So you can find how far your dog's height is from the mean. You can tell, okay, so my dog's height, since it's 170, it is one standard deviation right to the mean. And by this thing, we understand how well my data of the data set are spreaded. Just a second, please. So the takeaway from standard deviation is from the mean, how far is the data, is the data. Like you can tell that uh, your dog's height, which was 170, is one standard deviation right to the mean. So you can tell it. And the takeaway that is from variance, that the higher the variance is, the higher the dispersion is. I mean, the higher value you will get for the variance, your the higher value you will get for variance, the more spread out your data is. Suppose your variance is like 200, and it's like this, and your variance is 500. I'm just giving some random values, okay? And it's like this. So by this thing, you will understand, okay, so more data, the data are tightly around the mean. 200 means the data is tightly around the mean. the data lies more in the mean. And by 500, we can understand that the data are distributed. The data are very well spread. Suppose we have more larger variance, just random numbers. Uh, this gives you an idea that your data is very well spread and it's not concentrated only with the mean. And okay, I just missed one thing, that is zero skew or symmetrical distribution. You will also see this type of distribution calling as normal distribution or Gaussian distribution. We will get into this topic in the further sessions. And yeah, this is called bell curved because this looks some sort of bell, right? Anyways, so this is all the topic that I wanted to cover today. Okay, and the mean and the measure so we still have 10 minutes. The standard deviation and variance of Titanic dataset. We will show how we will calculate it in the Python code. You simply just have to write std. It's very easy in Python. np, the numpy thing, and dot std. What do you want to do? Standard deviation and the column or the array, which is age data. And then we got 14.51. And for the variance, you did what? np.var, then the age data, and you got 210 something something. Anyways, that was from my part. If you have any question, please let me know. Um, just let me know, guys, if you have any question or any topic you want me to explain more. Okay, so I guess that it is. Thank you, everyone. Thanks a lot for joining. I'll continue this session. Then in the next sessions, we will cover the inferential statistic. I will share this file with you, and please let me know if you have any confusion.